Hello student, welcome to the 8th day of online tutorial session. Today's topic is demultiplexer. So first we have to understand the meaning of the word demultiplexer. The word demultiplex means one into many. So what is the demultiplexing process is now? So demultiplexation is the process of taking information from one input and transmit the same over one of the several output. Okay. So this is actually the block diagram for 1 into 1 cross 4 or demultiplexer. Okay, so using this block diagram we try to identify few things. Okay, so first we are saying that demultiplexer is a logical circuit that receive information on a single input and transmit the same information over the several output lines. So this logical circuit, from this block diagram, we are able to identify that this circuit has one input signal that is I, okay, and M select signals over here. M is value is 2, S0 and S1, okay, and N number of output signals. N number of over here, N value is 4, Y0, Y1, Y2 and Y3. Okay. So what is the requirement of a S1, S0, that is select line over here. Okay. The select inputs determine to which output data input will be connected. As the serial data is changed into a parallel data, that is input cause to appear on one of the n output lines. So demultiplexer is called a data distributor or a serial to parallel converter. Here, because we know demultiplexer is known as a data distributor, just the opposite of the multiplexer, because multiplexer is known as a data selector. From several input it will select one, but demultiplexer just does the opposite operation. Okay, it will from the one information it will transfer to the multiple one. So that's why it is called data distributor. Okay, so from the truth table we need to identify how can we implement the logic circuit diagram. Okay, here I is the one input and S0 and S1 is the select line, and outputs are for Y0, Y1, Y2 and Y3. Okay, it is clear that the data input I is connected to Y0 when S1 is 0 and S0 is also 0. Okay, the data input I is connected to Y0 when S1 also 0 and S0 also 0. The data input is I is connected to Y1 when S0 is 1 and S1 is 0. The data input I is connected to Y2 when S0 is 0 but S1 is 1. And when the data input I is connected to Y3 when both the S0 and S1 is 1. So from this truth table we came to the Boolean expression for the outputs. Then what is the expression for the particular output? Okay, so this is actually the expression for the output. So for Y0 we are getting I, S0 bar, S1 bar. For Y1 we are getting I, S0, S1 bar. For I2 we are getting S1, S0 bar I, and for Y3 S1, S0 and I. Okay, this is actually the Boolean expression for the 4 output. Using this output Boolean expression, we will determine our logical circuit. Okay, this is our logical circuit. Okay, here we are using 2 NOT gate and 4 three input AND gate. Why ma'am three input? Generally we are seeing that two input AND. You can design multi input AND gate also. Okay, where you required why 3? Because S0 and S1 will pass and Y will be passing through each and every input. That's why we require 3 input AND gates. How many AND gates required? 4 AND gates required. And how many NOT gate is required? 2. Ma'am, why NOT gate is required? Because some of the time we are taking S0 bar value and some of the time we are taking S1 bar's value. So to represent the S1 bar and S0 bar, we require the NOT gates. Okay, so try to understand how we are getting the Y0. In a Y0, one fixed input is there, that is I, and another two is what? S1 bar and S0 bar. So this one is S1 bar we are passing and this one is S0 bar. Okay, this is complete for Y0. For Y1 we are getting I as a fixed input, and next two is what? S0 normally, and we are getting S1 as a bar value. For Y2 what we are getting? For I2, I is a normal one. Okay, S1 we are getting not, and S0 we are getting not, and S1 getting general one. For Y3, I is we are passing through the input 1 and S1 and normally S0. This is how we are trying to implement our 1x4 demultiplexer circuit. So thank you student. I am ending